So let's discuss breakdown of restricted Unix shells. It was a pretty good intro, actually. Basically covered all of the talk. So let's go through what we're going to actually discuss. So I'll first briefly introduce myself. Then we'll actually discuss what the restricted shells are. Then what are the different types of them and why do they even exist. We'll discuss some specific techniques of breaking out and a bit of a methodology around it. And also, I'll finally show you a bit of a demo of how some of those techniques can be done. And then we'll just summarize it and have some time for questions. So a little bit about myself. My name is Michal Knapkiewicz. I'm a penetration testing manager at Advanced Security Center at EY. I've got over 8 years of experience in the security industry, and I work with a variety of clients across different industries, performing various different types of assessments, web and mobiles, fixed applications and reverse engineering, network infra, and red teaming and social engineering type of assessments. So let's dig into it. So what is a restricted shell? Can I get a show of hands how many of you have actually encountered a restricted shell during your assessments? Quite a few of you. So as you can tell, they're relatively common. So what it actually is. So the Unix shell that basically restricts, as the name suggests, some of its capabilities that would normally be not available to an interactive user. So things such as using cd to change directories, to basically disallow you to enumerate or move around the file system, setting or unsetting certain environment variables such as shell or path, specifying any command names containing / in them, redirecting output, or using some of the built-in commands, and a lot more, depending on the specific configuration or whatever the hardware vendor is actually trying to restrict or prevent users from doing. So why do they exist? It's basically to provide an additional layer of security to prevent users from accessing the underlying operating system components, various configuration or other programs and data that's actually stored on the device itself. It often could be due to a copyright or warranty considerations. They basically don't want the users to tinker with it too much or maybe get access to certain things that they're not supposed to restrict the usage of the appliance itself just to a limited number of features that it was originally designed to. Those shells would commonly be found in routers, different network appliances, IoT devices, and some commercial off-the-shelf hardware. Why do we care? Well, as a penetration testers, we always aim to obtain unrestricted and fully privileged access to the underlying system. And as such, we kind of need to understand and know how to bypass those environments or break out of them. Whether you want to establish a pivot or initial foothold on the network, or just if you basically want to get to the underlying programs and maybe reverse engineer them and understand what else is actually happening underneath that, you first need to be able to break out of that shell. So what are different types? There are some native implementations, such as rbash or rsh or rksh, which is basically just a restricted variant of a common normal bash and sh and ksh shells. But there's also different implementations in various different scripting languages, such as in Python there's Al shell, and there's probably quite a few other ones in Ruby and whatever else. So let's talk about the specific techniques of breaking out and a bit of a methodology. So we'll kind of go in sequence and starting from obviously a bit of a reconnaissance, as in for any assessment, you just need to understand what's going on and what the environment looks like. Some quick wins, so things to usually check for that may be very simple and very quick to let us break out. And then we'll discuss a bit of a further enumeration, using SSH to break out, and a few ideas of getting a bit more creative with it. So step one, you basically need to learn as much as you can about the environment you're in. So a few things you would want to do. You would want to run env to see any environment variables to kind of understand what's being set, what things are available for our disposal, and what the environment in general looks like. You obviously want to echo path to find out what directories is the path variable set to. That usually indicates what directories you'd be able to run certain programs or tools from. You would want to echo a shell as well to find out what the actual shell is that we're in. Generally, it would be rbash or rksh, as I kind of discussed earlier. And then try basic common Unix commands that supposed to be restricted by a shell, but sometimes that things are actually misconfigured. So you would want to list directories, print working directory, try to change the directory, set and export certain variables, and try some common tools such as vim or vi, copy, move, those sorts of things. After you gather enough information, then there are some quick wins you can get. So if you're allowed to have a slash in your commands, then it's basically game over, because you can just simply run /bin/sh, and they'll spawn a new shell, and that won't be restricted anymore. If you can set path or shell variables, it's basically the same thing. If you can export path and then set it to /bin, then all of a sudden you have access to all of the tools that Unix normally stores under /bin and so on, which would allow you to in turn run sh and break out. Same thing with shell. If you can copy files into an existing path or the local directory, then it's also the same thing, because then you can just copy whatever binary you want from anywhere on the file system to your current directory, run it, and you have broken out again. So in that case, you could copy sh and then just launch it. Once none of that worked, then you have to do a bit of a more enumeration. So you would want to research all parameters and some additional, sometimes hidden or poorly documented functionality of all commands that you have available or are at your disposal. So some of the well-known programs that actually allow you to execute system commands, and often through them you can actually bypass shell restrictions, let's say FTP. You wouldn't really think that you can run local commands through it, but you can. GDB, more or less. So basically any default pages in the Windows file system, you can actually use them to execute commands as well. VI or Vim, it's basically, it's got a lot of different ways how you could use it to break out or bypass restricted shells. Secure copy, and even things like awk or find. Through them you can actually get quite creative and execute things as well. GCC obviously as well. So again, it really depends what you have available. I probably recommend going through the man pages and documentation of those things that you would have, that you would be able to run, to actually be able to understand, maybe there is a certain functionality that allows you to execute certain commands. Some programs actually invoke default pages, such as last that I kind of mentioned before, which then can be used to break out. So it's kind of like chaining multiple things together. So for example, man pages actually uses less as well to display the content of the man pages, I guess. So with that, you can actually use !bin/sh and then break out through it as well. Same thing with apt-get changelog or git help. All of them use default pages that then actually provide you with the functionality to break out. If you have ability to run Python or Perl or any other scripting language, again, that's basically a game over, because you can do quite a lot. And one of those things would obviously be running a system commands from wherever else on this file system you want. So it would allow you to launch bash or sh shells to break out. And you can also try writing to files. If you can write to files and overwrite an existing file, or even create certain scripts and launch them, then again, it's also something that you could use to break out. Another way of breaking out, it's basically using SSH. So when you SSH to a box that you're trying to compromise, there's a certain things you can run. So if you use -t command, it's basically you can provide a parameter, you can actually provide a command that will be executed before the profile of the remote shell is loaded. So often with restricted shells, you would have a lot of restrictions configured in .profile file, but with SSH-T, there's certain commands that are executed that you provide that are executed before the profile is loaded. So you can actually take advantage of it and launch certain commands before the restrictions have been applied. You could try basically launching /bin/sh and seeing if you can literally spawn a different shell before the restricted shell is loaded. Using the same trick, you can actually launch bash --no profile, which specifically tells bash to launch itself, but without loading the .profile file, where all of the restrictions are actually configured. Or finally, you can actually even try shell shock on some of the vulnerable shell implementations. Not sure if you guys still remember. It's maybe like a 7 years old vulnerability now, but it's still around in some of the more outdated hardware systems. And finally, sometimes you may need to get a little bit more creative and basically try to chain things that you have to come up with something that will allow you to execute certain things. One of my quite favorite or interesting tricks is the .history file. So what you can do if you have ability of setting up environment variables, you can actually set the hist file environment variable to any file you want to overwrite, which will basically make that file a new history file that stores all of the commands that have been typed in. Then you can set the hist size variable 0 to basically clear the memory of the commands that were typed in, and then right after that set it to 100 to capture certain commands. Then you start executing the lines that you actually want to be written to your file. So just simply type them in a console. And then once you're done, log out and log back in again. What would have happened, basically all of the lines that you typed in will be written to the file that your hist file was pointing out to. So effectively, using this method, you were able to write to a file, even though you may have been disallowed from doing that through the restricted shell. Also, good thing to note is that the original file permissions of the file you were pointing to remain the same. So if you have an ability of writing to a file that has execute permissions on it, then that file will retain those execute permissions, and you'll be able to actually launch it. All right, let's get to a demo. Let's see if I can actually get that displayed. All right. I'm going to run you through some of the I guess more of the interesting things that I have found throughout the different assessments and so on. So this is the environment I have created, just like a test environment with a few different ways of how you can break out. So we dropped into this shell, and let's just understand where we are. So the first thing we want to run is an ID command to understand who you are. So we're running as a restricted user. But one thing to note, one of the interesting things is that we also belong to pseudo group. So this already raises some questions that, okay, maybe we'll be able to do a few things here. Print working directory, we're in a /home/restricted as expected. Let's try to run sudo, but again, it says command not found. So it's already ringing an alarm bell saying that, okay, that's probably something restrictive going on there. Let's try to change directory. CD is also restricted. So that's basically our confirmation that we are in a restricted shell. We cannot move around. Let's try to copy file into local directory, see what happens. Again, cp command not found. So clearly we're running quite a limited number of commands. env, let's print the variables so we can see that the shell has been rbash, which is the restricted shell, which confirms what we thought. And then path is actually set to a dot, so the current working directory, and also the home restricted programs. So we can only run programs from /programs, whatever else is in there, and also from the current working directory you're in at the moment, which would be basically just your home directory. Okay, so with understanding what's happening, let's actually do some more enumeration and figure out what else is there on the file system. So let's see if we can export the variable. So first thing you want to try is if we can add another directory to the path variable, but you can see that the path is actually read-only, so we cannot modify it. So we are restricted to only be able to run things from programs. So let's see what's there. So it looks like we can only run chmod clear editor, env, id, ls, and ssh while we're in this shell. So editor looks quite interesting. let's see what it is. So when we launch it, you can see that this is actually Vim. And this is something that I've seen actually quite a lot. Some hardware vendors would grab usual common tools and would kind of rename them. So I've seen certain cases where simple man pages were renamed, assist or help or something like that. So you have to be quite observant. Whatever you run, it may, make it appear that it's something different, but it's actually some common things. So with Vim, there are quite a few things that I've already kind of discussed and showed you how you can break out. So with Vim, very quick, !bin/bin/sh. But unfortunately, this one didn't work. It says that you cannot specify slashes in command names because we're running in a restricted shell. The reason why this didn't work is because Vim is actually using a underlying shell as a default shell that it has been spawned from. So in that case, rbash. So it kind of makes sense why it doesn't allow slashes in the names. But there's one quick trick what we can do. We can actually, with Vim, set default shell to something else. So if we go set shell bin/sh, it will actually modify the working shell of Vim from rbash, which is by default at the moment, to /bin/sh. And then if you simply go :shell, it will launch it. So now let's see what happens. cd/, we can actually change working directory. We can list the files in the file system we have broken out. Let's try sudo. Still doesn't work because we need to fix up the path, because our path is still pointing to the old thing. But now because we have broken out of the shell, we can actually modify it. The path variable is now writable, and we'll be able to run the commands. Luckily, as a sudo, I can run everything, and we just became root. That's obviously just a test environment, but I've actually seen exactly that multiple times. So what happens is the hardware vendors would often just assume that the restricted shell is enough to break it all, to protect it all, and then when you break out, often further privilege escalation is quite simple, literally with just sudo. So that was the first technique. The second example is let's understand what else is happening in the environment. So let's say if we didn't want to take this approach, or if that didn't work for some reason, what else could we do? So let's figure out what's happening on the file system. So let's list print working directory. We're back in the restricted shell in this case. You can see that we have read, write, and execute permissions on the current directory in our home directory, which makes sense, but that's quite a good thing to note. Also remembering that path actually executes from current directory. So let's just create a test file using the editor. As you can see, the test file has been created, so that kind of confirms that we can actually write to the current directory. So with that, there's a few things. Remember I mentioned that if you can copy and execute files in your current directory, that's a pretty good way of how you could actually be able to break out. So we tried copy before, that didn't work, but there's different ways what you can do with it. So again, Vim comes to the rescue. One of the cool things with Vim is that if you point it to a directory, you actually get a bit of a file browser. So if you go editor.current directory, you can see you can actually browse through the file system using Vim, which is kind of cool. And with that, you can actually go out and browse the whole full file system, which is super handy. So let's go to bin and let's find a dash binary, which is basically a shell, right? So that displays just a binary file in Vim. But what we can actually do through Vim, you can actually copy this file into your current directory. So if we simply go :w %t, what will happen is the contents of the file will be grabbed the way they are, so in the binary form, and put in your current working directory. So what happened here, you can see that the dash has been written, and if we exit, you can see the dash has been copied into our current directory. So that's pretty good. We already have a shell that we can actually try to execute from our current directory. But there's a problem. It has been copied with read, write, read permissions, so we cannot execute it. So that's one challenge. However, luckily, as you remember, we had chmod as one of the programs we were actually able to run, purely by coincidence. So using chmod, you can easily change permissions of the file you've just copied to add the execute flag to it, which is what we're doing here now, and just execute it. Here you go. So you have another shell that you can just simply use to break out and move around. And it's the same thing as before. Fix up the path variable, launch sudo, and you're in. Same thing. So there was a second example of copying files. Now we can move on to the third one and the last example. What else can be done? So let's say neither of those two other things I showed you worked. Again, it's all about enumeration and getting creative and understanding things that you have at your disposal. So let's have a look at the bash profile file. As I mentioned, that's where often the restrictions are applied, right? So if we look at it, it looks kind of typical bash profile. So what do we have here? So if the .bashrc file exists, then basically load its contents into the the environment, and then just set the path variable to just restrict it to just running things from /programs. So there's a few interesting things here because you can note that there's no .bashrc file, right? So we could actually potentially create a file and add our own little things to it as well. That will come in later, but I would like to focus on doing exploitation through SSH now, because you can see that the SSH is actually available. So let's see what can be done here. Remember how I mentioned the -t parameter for SSH? That's basically what we can use here. So let's try to SSH back to localhost and go -t bin bash, and then see if we can execute that. Unfortunately, this one says again, cannot specify slashes in command names because we're running as rbash. So what can we do in this case? If you recall in the .profile file, the path is being set to just /programs, right? But because we're using -t, that actually executes commands before that path is being set in a profile file. So technically, the path should be, the full path available that would normally be on the Unix system. So what if we just call again SSH localhost -t, but we just say sh, because that should already be in the profile in a path variable. If we run that, you can actually see that it worked. So again, using the same thing, you can just break out and do the same thing as I showed before. So this is one way. Again, let's go back. We're in a restricted shell again. You can do exactly the same thing with SSH, and then run bash if that's more of your preferred shell with --no profile. As I mentioned before, it will do exactly the same thing as running sh variable, except it will launch bash without loading its profile, and same thing, we're broken out. And finally, again, confirm you were in a restricted shell again. As a final example, I mentioned about the .bashrc, which is actually loaded before everything runs, right? So what if we just create our own bashrc, because we have permissions, we have rights to do it. So I can basically add whatever I like in my bashrc to just go bin/sh immediately. If I write that file in and then SSH again locally, what will happen? My bashrc will be actually executed, and same story. I'm already broken out because I'm using the bin/sh that I've actually configured myself. And that's the way how you can also break out. So these are basically the 3 different use cases or examples of how things can be abused to actually break out from shells. So in summary, sometimes restricted shells can make an assessment a little bit more tricky, but you kind of have to be very observant, see what's available in the environment, and understand what's out there for your disposal to actually try to chain things together and break out. There's various techniques. This is basically just a tip of an iceberg that I've covered, but some of the common things that I've seen around. There's a lot more different ideas and methods that you could use. GTFO bins is a very, very good reference, or basically it's a list of almost all imaginable Unix binaries that are there that can actually be used to bypass things like that. It will tell you what are the different or hidden or not really documented parameters or commands that you could use to either privilege escalate or break out from shells like this. Again, enumeration is key. Understanding what you're dealing with and what environment you're in is very important, and also a little bit of creativity just to try to chain things together. And as I demonstrated, after breaking out, further privilege escalation may often be quite simple, just with sudo, because again, there's quite a heavy reliance sometimes vendors put on the actual restricted shell that will solve all the problems, but it's not always the case.